So, lesson 3.5 here, the polygon angle sum theorems. So last lesson we focused just on triangles and how the three angles add up to be 180. Now we're going to get into, well, what about polygons bigger than triangles? And that's what we're going to focus on today. But first, the kickoff here, so we're going to find the value of x and y. So let's start with x. So if we cover up this part of the triangle, and we just focus on the little triangle there, we have 2 to the sides, we're missing their 1 there. Well, we know from last time that if we add the 3 angles up, we know that's going to be 180. So 39 and 65, if we add them together, we're going to get 104. And that's equal to 180. So if we subtract our 104 over, x is going to end up being 76. So now that we know this is 76, now we can find y. Now we can't just focus on that triangle there because that triangle's got 2 unknown values. However, what we can focus on is this part right here. Those 2 angles make a straight line. So if we know one is 76, the other one with that 76 would be 180. So 76 plus our y is equal to 180. So we're going to subtract the 76 over, and we know y is going to be 104. So, triangle angle sum theorem from last time, we knew the 3 angles add to be 180. Well, now we're going to get into other polygons. So, first off, a polygon is going to be a closed plane figure with at least 3 sides that are segments. So a triangle counts as a polygon. Just think of many-sided, poly, many, gon, side. So many-sided figure. Now, we can't have 2 because if we have 2 sides, either it's going to be open or they're going to be the same line. So we need at least 3 sides, and they intersect only at their endpoints and have no sides that are collinear. So no sides that are on the same line. So when we name these polygons, we're going to name them by their vertices in consecutive order, either clockwise or counterclockwise. So what I mean is this. So if I draw out a hexagon here, we're going to call this, well, hex go. So what I'm talking about naming them is, say if I start at H, I would go around in consecutive order. So the next one I'd hit is E, then X, then A, then G, then O. Now, I could go the other way. Say I start with O. I can go the other way around and go O, G, A, X, E, H. So, pick any point and you just name them consecutively, either counterclockwise or clockwise. That's how we go about that. So if we want to name this polygon, so as far as naming it, we name it using the points. So we don't say, hey, this is a hexagon. That's going to be when we classify it in a little bit. But for right now, when we name it with the points. So we could say, hey, let's go B, C, D, E, F, A. Again, not really going to matter. Just pick a point and go either clockwise or counterclockwise with it. Vertices are going to be all of these corners, so where the points are. So we have A, B, C, D, E, and F. Okay. Sides take 2 points because we're naming segments. So like AB, and we put our little dash on top. BC, CD, DE, EF. So we got 1, 2, 3, 4, 5. Our last one, AF. So we have our 6 sides. Angles and the vertices are going to be the same thing, except we need our angle sign. So angle A, angle B, angle C, angle D, angle E, and angle F. Okay. So, typically on a quiz or a test, I'm going to say, hey, name this one way, or give me a vertice, give me a side, give me an angle. You won't have to list them all out, but here we're listing them all. So you kind of know what's going on there. All right, so next part about this is when we get to classify them, we're going to classify them with two different parts. First, convex or concave. So convex is when we have no diagonals with points outside the polygon. So like this one here would be convex because any diagonal I draw, so any diagonal connecting two of the sides is going to be completely inside the shape. The other side of this is concave, where at least one diagonal will have points outside the polygon. So later on when we get to the star, this star is going to be concave because if we connect these 2 points, we're outside the shape. Or say here, say here, say here. Even though like if I connect these two, we're good. But this one over to here, we leave it. So there's points where we're going to leave it, then it's going to be concave. Now, the second part of it is we're going to name it by how many sides it has. So like this top one here, it has 6 sides, it's convex. So we would call it a convex hexagon. And that's its classification. So don't get that mixed up with naming. Naming, we use the sides, but classifying, where it's either going to be convex or concave, and then the name according to how many sides it has. So, like I said, when we're classifying this one, we know it's going to be convex. I already pointed that, or concave. I already pointed that out. So this will be a concave. And now we're going to count the sides. So if I start up top here, we're 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if we come over here to our chart, 12-sided figure is a dodecagon. So this is a concave dodecagon. All right. So when we're talking about naming a figure, we name it with its points. If we're classifying it, we classify it like this. Either it's concave or convex. And then whatever the name is, that goes with the number of sides. Now, if we get bigger than dodecagon, or like an 11, we don't have 11, we don't have a 14, we would just say 14agon, 15agon, 24agon, whatever sides it is, gon. So 24agon, 24 sides. So, talked about it at the beginning there. Triangles, we know they add up to be 180. Well, when it comes to polygons, n is our number of sides. So it's going to be our number of sides minus 2 times 180. So if it is a hexagon with 6 sides, we would go 6 minus 2, which is 4. 4 times 180 gives us 720. So the measure of the angles of a hexagon would have to be 720. So if we're looking at a 15agon, we would go 15 minus 2 parentheses times 180. So 15 times 2 is 13. I should curve it this way. Times 180. So if we put that in our calculator, 13 times 180, we end up with 2,340 degrees. So on a 15agon, all of their angles on the inside will have to be 2,340 degrees. Now, where that comes in handy is if we're solving problems like this. So, find the measure of y in the pentagon TVYMR. Now, what you might not see because it's kind of cut off is this last side here. There is a box and there is a box here. So, these are both 90s. We have a 90 here. This one's 135. We're missing y. So, what we're dealing with here is we would take the measure of angle M plus the measure of angle R plus the measure of angle, so for MR, this must be T and V, Y. So knowing they name it going around, so MR, T, V, Y, MR, T, V, Y. Okay? So the measure of angle T plus the measure of angle V plus the measure of angle Y has to equal, well, what does it equal? Well, we know we have 1, 2, 3, 4, 5 sides. So we do 5 minus 2 times 180. So in other words, this is going to be 3 times 180. ends up being, I don't know why I can't think of this off the top of my head, 540. Wow. Sorry, guys. So 540 degrees. So this is going to equal 540 degrees. So we know angle M is 90. We know R is 135. We know T is 90. We know V is 90. But we're still looking for the measure of angle Y. But we know in total it's got to be 540 degrees. So if we add these all up, so 90, well there's 3 of them, times 3, plus 135, leaves us with 405. So 405 plus the measure of angle Y equals 540. So if we subtract 405, the measure of angle Y would equal 135. So that's how we can find angles we don't know with bigger polygons. Use the, we know they're all going to add up to be whatever this value is when we do it in that equation, n minus 2 times 180, n being the number of sides, and we can still find that. Now, just like where we talked about it with triangles, each vertex we can have a exterior angle be drawn. So if we extend these out, we would have these 3 exterior angles. If we have a quadrilateral and we extend these out, we'd have these 4. If we have a pentagon, we'd have these 5. Now, if you add these all together, they're all going to end up being 360, which leads us to the next theorem here, Theorem 315. So what that's saying is all of the exterior angles of any polygon is going to be 360. No matter what the polygon, all the exterior angles would be 360. So that's where, I'll go back just a second. So if we're looking at this one here, if we add these 5 up, we know they're going to be 360. So that's where they're getting this from. So if I add up all those 5, we know it's 360. It doesn't matter if it's a triangle or a 15-agon. The exterior will always have 360. Now, last few things here. You can't have equilateral polygons. Equilateral just means all sides are congruent. So a lateral means sides equal sides. Think of it that way. They can also be equal angular. So all the angles are the same. So if all the sides and all the angles are congruent, we call that a regular polygon. And that is it for this lesson. So let me know if you have any questions. Otherwise, until next time, we'll talk to you later.